Automation Direct presents What Is? Networking Edition. What is Ethernet IP? If you're new to automation circles, haven't yet had a chance to work with Ethernet IP, or maybe just want to know a little more about this industrial communication protocol, watch on. Ethernet IP is definitely worth looking into. Robust, reliable, and fast, Ethernet IP is an application layer protocol used throughout industries worldwide, thanks in part to its adoption by some of the most prominent controls manufacturers in the business. By some estimates, it holds a 30% market share of the industrial Ethernet market and accounts for over 20% of all new communication implementations, Ethernet and otherwise, in factory automation globally. Ethernet IP can be thought of as having two parts: the Ethernet and the IP. The Ethernet part refers to the traditional Ethernet technology that Ethernet IP adapts. In other words, EIP uses the physical and software Ethernet standards provided in IEEE 802.3 for its transportation, the transport, network, data link, and physical layers in the OSI model. This gives EIP many advantages: the ability to utilize off-the-shelf Ethernet hardware for its network, for example, and the use of standard IP addressing and subnetting. It takes advantage of both the TCP and UDP protocols that Ethernet uses. Recall that TCP is a connection-oriented protocol, and it employs handshakes and acknowledgments to ensure that a connection is intact and that the target device has received the sent packages successfully. UDP, on the other hand, uses a connectionless communication scheme in which transmissions are not acknowledged and which generally require much less overhead. We'll return to these two different schemes in a minute to see how they relate to the types of Ethernet IP communications. The other half of the Ethernet IP equation is the IP. The potentially confusing designation does not refer to the Internet Protocol, as in IP address, but to Industrial Protocol. Specifically, Ethernet IP is built on the Common Industrial Protocol. CIP is an object-based protocol that handles data representation, connection management, and messaging, but does not incorporate its own transport and physical layers. Therefore, it can be paired with other protocols that handle the data transport. CIP paired with CAN technology is DeviceNet. ControlNet and CompoNet both use CIP with their own transport and physical layers. Ethernet IP, CIP adapted to Ethernet, is by far the most widely used of these. All of these, along with CIP itself, are administered by the Open Device Vendor Association. The ODVA manages Ethernet IP as a certifiable standard, meaning that all manufacturers and vendors implementing the technology must adhere to a declaration of conformity to maintain a license for its use. Interoperability among certified products from different vendors is assured. In EIP communications, we broadly categorize components into originators and targets, with the originator being a master, like a PLC or other controller, in command of one or more target devices, sensors, or other field devices. As was mentioned before, Ethernet IP utilizes both TCP and UDP protocols for different types of communication between the originator and target devices. Explicit communication uses TCP in a request-response arrangement. Each message opens a point-to-point connection with an establishing handshake, receipt acknowledgement, etc. Each message also explicitly spells out for the target what information is being requested or sent. This object, this class, this instance, formatted precisely this way, and so on. The explicit message has a lot of overhead and carries a lot of data, so of course it is relatively slow. For this reason, explicit messages are sent asynchronously, only when required. They are often used to carry settings and other non-time critical data. In explicit messaging, the originator is typically called the client, and the target is the server. Explicit messaging uses port 44818. Implicit messaging, sometimes called I/O messaging, on the other hand, employs a constant stream of data from the target device, called an adapter, to the originator, called a scanner, transmitted via UDP. Implicit messaging fits a producer-consumer communication model. There are no requests and no information about what the scanner needs, no handshake checks, and no receipt acknowledgments. Since the adapter will be sending a steady, repeating stream of data, a missed message is not a significant concern since another is on the way within milliseconds. The data the adapter sends has all been pre-configured in the scanner, either manually or by the provision of the adapter's electronic datasheet. The EDS is a simple ASCII file that identifies all the adapter's data, so the data stream's identity is understood by both devices before communication even starts. Implicit, in other words. For these reasons, implicit messages are lighter and much faster than explicit. Implicit messages are considered to be soft real-time communication and typically contain field I/O data adapted into communications. Implicit messaging uses port 2222. There are a great many resources out there for anyone wanting to delve more deeply into some of the topics we've touched on here. We hope this gives you a starting point for your exploration of the Ethernet IP protocol. To learn more about Ethernet IP-capable PLCs and field devices, visit AutomationDirect.com. Click here to see other videos about industrial communications. Click here to subscribe to our YouTube channel.